Welcome everyone. Are you ready to become a shear leg detective? Let's dive in and explore the fascinating world of shear leg reduction factor. The shear leg factor is a critical concept that helps us account for uneven stress distribution in connected members. By understanding the reduction factor, we can design safer and more efficient structure. When uneven stress is occur in the members, then we will minimizing the net area by a reduction factor. In last lecture we had discussed the first category for U. There are total 5 categories for finding the reduction factor U. In last lecture we had discussed the first category for finding U. In this lecture we will be exploring the other 4 remaining categories for finding U. This reduction factor will be multiplied by the net area, so we will get the effective area. This effective area will be used in the design of tension members. In design of tension member, there were the 2 limit state. One is the yielding and the other are the fracture. In fracture, we will use the effective area. So it is very important. For effective area, we will need the reduction factor and the net area. So for reduction factor, we had 5 categories. In this lecture we will be discussing the remaining 4 categories for finding the reduction factor. The second category for finding the reduction factor for plates. So there are 2 types of plates connection. The number 1 is bolted plates. When the plate is connected with a gusset plate or other elements by bolted connection, and if it is welded by other elements with the welding connection. So there are 2 categories further in plates. One is bolted plates and another is welded plates. So first is for bolted plates. For bolted plates, since all the cross section has only one element, so all elements are connected, so for this U will be equal to 1. In other cases, we can also determining the U by equation method. In last lecture we had discussed the equation method that is 1 minus x bar divided by L. For bolted connection we can use the equation method too. Remember this. And the other is the welded. For welded connection, what will be the value of U? Here when all the sides transverse and longitudinal side is, remember this, in the direction of load the side is of the connection is called longitudinal, and the perpendicular direction side will be called transverse. So here this is the longitudinal and this will be the transverse because the load is in this direction. So when the all sides, transverse and longitudinal sides, are welded, then U will be equal to 1. Remember this. When only longitudinal sides are connected, then we have 3 conditions for this. When only this side are connected in the direction of loading, then this side will be called longitudinal sides. If the longitudinal sides are connected, then we have 3 conditions. So number 1 condition is that for length, the connection length greater than or equal to 2 times of width, then U will be equal to 1. The connection length is this, that the length of the weld. So this, if this length is greater than 2 times of W, then the reduction factor will be equal to 1. If the connection length is greater than or equal to 1.5 times of width and less than 2 times of width, then the reduction factor will be 0.87, and for this condition the reduction factor will be 0.75. This will be the for the longitudinal welded connection for in plates. And the number 3rd category is for round hollow structural steel. When the length of connection is greater than 1.3 times of diameter, this is the threshold. When the length of the connection is equal to or greater than 1.3 times of the dia of the hollow structural steel, then we will use this category. For this round HSS bar, when length is greater than or equal to 1.3 times of diameter, then the reduction factor will be equal to 1. Remember this. This will be the dia and the connection length will be denoted by small l. So here when this condition occur, then we will use directly u equal to 1. When the connection length is greater than or equal to the dia and less than to this condition, then we will use the equation method as we discussed in last lecture. That was the first category. For this we are using the x bar by this formula. Only this formula changes from first category. So x bar will be diameter upon pi. And the fourth category, for finding the reduction factor, we will be using the alternative values for single and double angles only. So for this it depends on the number of fastener. If the 4 or more fastener in the direction of loading, then we will be using the reduction factor u equal to 0.80. Here you see that this is the direction of the loading. In the direction of loading there are 4 number of bolts fastener occur. So for this, if the number of fastener in the direction of loading is 4 or more, then we will be using directly without calculation the reduction factor 0.80. If 3 or less fastener occur in the direction of loading, then we will be using the 0.60 reduction factor. Here you can see that 2 or 3 fastener in the direction of loading. Here 3 fastener occur in direction of loading. For this u directly equal to 0.60. This is the 4th category is the alternative value for single and double angle. So here the 5th category is the alternative values for the equation which we had discussed in last lecture. This equation, that 1 minus x bar divided by L. For this equation we had different alternative values. The first one is that it account for W shape, M shape, S shape, HP shape and T's cut from these shapes. So we had discussed already different type of structural steel. For these, the alternative value is the first is that connected through the flange 3 or more fastener. When 3 or more fastener are connected in flange, remember this, I highlighted the flange at least width. For the first, when the flanges had 3 or more fastener in direction of loading, for this we had condition that the width should be less than or greater than 2/3 of the depth. Remember this. When at least value is the equal width at least 2/3 of the depth, then we will be using 0.90. For this we will be doing calculation. If this is greater than 2/3 of the dia, then we will be using this. If it's not, then we will not using this value 0.90. If the width is at least is less than, if the after calculation 2/3 of the depth, if its value is less than the width, then we will be using 0.85. Remember this. This will be the two condition for flanges when the 3 or more fastener are connected. If the width is less at least 2/3 of the depth, then we will be using this value. If the width is less than 2/3 of the depth, then we will be using 0.85 reduction factor. And the last is the connected through web with 4 or more fastener in the direction of loading, then we will be using u directly 0.70 without any calculation. For this we require to counter this condition. For this, if 3 or more 4 or more fasteners are connected in web, then we only using directly the reduction factor 0.70. So in this video lecture we had discussed the remaining 4 categories for finding the reduction factor. Number 4 and 5 categories for the alternative values, and the number 1 was the equation method. So for the equation method, these are the alternative values. So hopes you understand this. very well. Thank you everyone.